Okay, we know that this question is going to involve power is equals to F times V. But the first thing we should find out is to make use of this information here to calculate the power. Okay, so we are told that at speed, when the train is traveling at this speed, it's accelerating at this rate. So what are the forces that's allowing us to achieve this acceleration? Well, there must be the propelling force, which should be more than enough to overcome the frictional force. So let's apply Newton's second law onto the train. So we have the forward propelling force minus away the resistive force should be equals to the mass of the train times the acceleration of the train. So let's put in all the numbers that we have. The question did tell us that the frictional force is constant, is 50,000 newtons, and the mass of the train is also given, and of course the acceleration was 0.5 meter per second square. So from here we obtain the value of the propelling force, 200 kilonewtons. So this force was 200 kilonewtons when the train is traveling at this speed. So let's now calculate the power that's developed by the locomotive. So power is F times V. We know that when it's going at 10 meters per second, the locomotive is providing a propelling force of 200,000 newtons at a speed of 10 meters per second. So from here we get the number 2 megawatt. So the question told us that the locomotive is providing a constant power, which is 2 megawatt. So now this force is larger than this force, so the train is accelerating, it's going to pick up speed, its speed is going to go higher than 10 meters per second. So as the speed reduces, as the speed increases, the propelling force is going to decrease because the locomotive can only provide a constant power. So as the train goes faster and faster, the propelling force will become smaller and smaller. So how do we relate this to the maximum speed? When the train is going at a maximum speed, it must mean that the acceleration is 0, right? The reason why it doesn't accelerate anymore must be because the net force is 0. So we were told that the frictional force is constant. This number here is a constant frictional force. So when the train reaches its maximum velocity, it must be because the propelling force is exactly equals to the frictional force. Alright, so since the frictional force is a constant 5.0 times 10 to the power of 4, when the train achieves maximum speed, the propelling force must also be 5.0 times 10 to the power of 4. Okay, so now again, we know that the power is F times V, and it's a constant power, so the power remains as 2 megawatt. Let me just copy this thing down. It's actually just 2 megawatt. When it's going at maximum speed, we know that the propelling force is this. And that will be the maximum speed. So just do the calculation, you get the maximum speed to be 40 meters per second. Okay, ta-ta.